Hello. So we will mod two BIOS files for x79 platform to add support for bootable NVMe drives and resizable bar. One BIOS is from Asus board and the other one is from MSI. And we will first mod the Asus one because it's a lot easier because it doesn't give you any problems. And then we'll do the same but with MSI to show you how to fix common problems you will see. Well, this folder structure is available for download in the description, and inside it you will find all files necessary to complete this procedure. Well, in the folder BIOS you place your BIOS that you want to mod. The tools folder contains all the programs we need to actually do the mod. DXC folder contains drivers that will inject into BIOS, and patch and DCT folders are contain files we will use to modify our BIOS. So let's start with the Asus one. So first of all, from tools folder open UEFI tool, this one without NE extension. Okay, and now we'll open the original BIOS from the BIOS folder. Click on File, Open Image File, go to BIOS folder, and if your BIOS doesn't show up in here, then expand this and click All Files because it depends on the extensions that your file has. Okay, so let's open this one. And so in this program we will not touch this BIOS. This BIOS, original BIOS, is just as a reference point to see if all the procedures have been done properly. What that means is that inside this BIOS, you can expand it, BIOS region, there is a structure we must preserve, and that is this one structure. So we need to have pad row fixed, and it cannot change because the BIOS will start to behave unpredictably if anything happens to this structure. So let us return to the BIOS folder and copy our BIOS first into the DXC folder. Okay. So to inject the drivers into our BIOS, we can use two methods. So one method is to use this UEFI tool. You find the section of the BIOS containing DXC drivers. In this case, that is the third header from the top, and you'll see DXC, and starts with core DXC. At the end of this section, the last driver is project DXC. So we could use UEFI tool, right click on the last driver and just pick insert after. But sometimes with UEFI tool you have padding errors. It means the program changes this structure. It won't happen on this particular example, but you may experience it. So to make sure that everything is functioning properly, we'll do the same thing but with another program called MMTool. So let's start this program and let us open the BIOS we copied into the DXC folder. I'll click Show All Files and let's select Rampage 4. So as you can see, the structure is the same. We have a core DXC, runtime, Asus, PTT, and other stuff, exactly as in UEFI tool. So we now know that we have to scroll down to the last driver, project DXC. As you can see here, all the drivers are in the volume number 2. So we can just search where the volume number 2 ends. It is here. And we see that project DXC is the same as in UEFI tool. So we are in the Insert tab and click on the Browse. And we will first add NVMe driver. Click Open, Insert, and then again navigate to the end of the volume 2. Click on DXC and now select ReBar driver, Insert, and just save this image and close this program. So to compare the two files, back in the UEFI tool, let's go to File and Open File in a new window and select this file from DXC folder. Let us expand to the same section, and we'll see that the structure of these paddings is preserved. As in the original page row, that is the same here. So this file is correct and we can continue to the next step. So let us copy the file from DXC to patch folder. Now, for convenience, I will rename it Asus.rom, just so I don't have to type as much. Okay, let us copy the path to this folder and start CMD. Press the Windows button and start typing CMD for command prompt and run as administrator. Yes. So type in CD space and paste your path. Okay. So what we'll now do is start the UEFI patch command, UEFI patch, and the input is the name of our file or of our BIOS, in this case Asus.rom. So we see that the numerous bytes have been changed in the BIOS, and let us now check if the padding structure remained correct. As you can see, this UEFI patch program created a new file with extension patched. The original one is not touched, so we will need to open this file. So in UEFI tool, let's again open a new window. Go to patch folder, show all files, and select this patched one. So let us see the structure. Page row, so everything is okay. We can proceed to the next step. Let us copy this patched file into the folder named DSDT. Remove the extension patched. Yes. Now, again, sorry, I forgot. Open this file, this patched file from the folder DSDT again, but not with UEFI tool 28, but with the program UEFI tool NE. So let's start it. File, open image, DSDT folder, open the file, and now we have to navigate to the specific section of this BIOS file. Let's go to the drivers section, third from the above. We will see the list of drivers, but now we need to extract the AMI board info. So we do it by selecting that entry, expand the compressed section, click on PE32 image, right click and select extract the body, and just delete everything before and after. Let it be named AMI board info.efi. Save. So we can close this UEFI tool NE. Let us navigate in command prompt to the DSDT folder. And now we will do the DSDT patch. So let's switch to this. So we are now at step number 3. So we have to run AMI board info tool program. Let's copy all of this and paste it into the command prompt. So this program extracted this file, dsdt.aml. So we will now use the other program, EASL, and point it to this new file, dsdt.aml. And this program created dsdt.dsl. Let us rename it dsdt mod.dsl. And now to fix this dsdt file, we need to open it in Notepad++. So if you don't have it installed, please install it, because it won't work with a normal Notepad. Right click on the file and select Edit with Notepad++. So let us now go to the guide, and we are searching for x79 DSDT patch section. So first step is to find in our DSDT file this value. Let us copy it and search find. Let's find next instance. Okay, there are only 2 instances. So let's go to the first. Now select all of this code from the guide, copy, go back to Notepad. So we are at the first instance. You will see it is starting with CRS1, then you have Y04, and in this body you have Y05. We need to select all of this between curly brackets and paste our code from the guide. Justify the code. And okay, once it's justified, let us copy it again and let us go to the second instance. Just click next in the search. Okay, in the second instance we have CRS2. We have different variable YOA, and in the body we have YOB. So we will have to change our code accordingly. Let's select everything inside, paste. So we have to change this to CRS2. This variable needs to be YOB. And these names, since we have in the first instance, we have variables M2LN, we now have to increment them by 1. So let's say M3. And we also need to change this to 3 in the second part. Okay, and now let's just save the file. So the next step is to fix the DSDT errors. So in this instance, the first thing that we need to fix is this one. We have to search in the BIOS for the entry PNP014, PNP0C14. Okay, we have one entry and we have the other. So what we have to do is rename the first one to all caps, so no small letters. The second one is okay, but the first one we have to change to PNP0 uppercase C. Okay, that is one fix. Save it. So the second one is to create a regular expression in the search and replace on your Notepad++. So go to the search, go to the replace tab and select regular expression. Now copy all of this to the find what tab field and all of this into replace with and click replace all. Okay, now the next step is the same but with these commands. So we need to find this one and replace with this. Replace all. Okay, and the final change we need to do is where this one it's here, sorry. We have to search, but normal search, go back to the find tab and type Y04. So we need to change the value of this range to this. So copy it and paste and save. So that is all the modifications we need to do to this file. And now we need to compile it back. So we'll write EASL DSDT mod, our changed file.dsl. So as you can see, we have 0 errors, and warnings and remarks you can safely ignore. If we had one error or any number of errors, we'll just go here and search for the entry where that error is, and we will see this description what we need to change. But now we have this file compiled and we need to merge it into original AMI board info. So this is step number 7 from the guide. So we need to run this command. Go to your prompt, paste it. Okay, so now we have a new file created named AMI board info mod.exe. Okay, so what we need to do now is go to UEFI tool, open the BIOS in a new window from our DSDT folder, select the BIOS, open it, go to the AMI board info section, expand it, compressed section, select PE32 image, right click and replace body. And you now select AMI board info mod, our new file that we created. Open and save the file. Something like test.rom. Open the file so we can check for errors. And as you can see, there are no errors here. The structure is the same, pad row, so this BIOS is ready to be flashed. I copy it from DSDT folder here into one step above, and now we will modify this file with BIOS to allow above 4G to function properly. So from the tools folder, open AMI BC program, open our BIOS, test.rom, and now we search for above 4G entry in the BIOS. So in this example, it is under advanced PCI subsystem settings. And here we see we have a fail-safe and optimal settings. Fail-safe will be active when you first time flash the BIOS or when you make a clear BIOS. So we only need to modify optimal, because in that case, when you enter BIOS and click on Set Defaults. It will load optimized defaults, and by stock configuration above 4G will be disabled, and after you load optimized defaults it will be enabled, just so if something happens that you can go back one step before and change the settings in your BIOS if there will be something wrong with it. So let's above 4G to enabled, and for it to work properly we must disable CSM, the compatibility support module in BIOS. Go to the boot section, expand it, compatibility support, okay. So as failsafe you can leave it as it is, but as optimal settings disable it. And all those drivers below it, just put UEFI only, UEFI first. Okay. Also, if you have modded GPU BIOS, make sure that secure boot is for now. You can enable it if you need it, but for now just don't use it, because if you have modded GPU BIOS, the secure boot of course won't work. Now we just save this BIOS. Okay, ignore this warning because Asus has capsule on the BIOS. Never mind, it doesn't matter. Okay, close the program. Okay, save it again. Okay, and now to flash this BIOS with the Asus flashback, for Rampage formula we need to rename it R for F cap. So now we can use the BIOS flashback function to put this BIOS on our system, and everything will be fine and working. Once you flash the BIOS, loaded optimal settings, and of course changed everything as per your system as you use the settings. Once when you're in Windows, you also need to run this tool, ReBar state, to actually set the size of resizable bar. So in my case it is set to 32 or unlimited. So you just type here 32, press enter, and you need to restart the system. Once the system is restarted, it will detect the hardware change and ask for another restart. And after that, go right click on your start menu, go to device manager, view the resources by type, and under large memory you will see your GPU. You can check that by running GPU Z. Go to Advanced tab, select resizable bar, you will see it enabled, and you will see the size. So that is it for the Asus BIOS, and now we will continue to MSI BIOS. Okay, so now we will mod the MSI BIOS. So as first step, let us copy the BIOS from the BIOS folder to the XC. This one here. Go to the Tools folder, open UEFI tool non-NE, and open the original BIOS from the BIOS folder, just so we can have a point of reference. Well, first thing you can see, this file has a different structure than Asus BIOS. So the driver section is located here. So this driver section has a padding structure like this, pad row, but the section after it also has a padding structure at the end, pad row pad. So and we will need to preserve both structures. So let us first add the drivers to the BIOS. So start MMTool, load our image from the DXC folder, scroll down. As you can see, the drivers here are located in volume number 1, core DXC, runtime, blah blah blah. So let's scroll to the end of the volume number 1. The last entry is mflash, the DXC, as in UEFI tool. That is the last DXC driver. So click on that, insert tab, and browse for NVMe. Insert. So go to the end of the section 1, select the original driver, browse, and now add ReBar. Open, insert, and save. So let us compare this file from the DXC folder to the original one to see if any changes occurred. So in the second section, the structure is the same, pad row pad, and in the first section the structure is also the same, pad row. So we can proceed to the next step. So copy our injected file into the folder patch. I will rename it MSI.rom. Now let us copy the path, start CMD, and type UEFI patch msc.rom. So in this case only 2 changes have been made, and we have now our patched file, and let's see if the structure of this patched file is the same. So let's navigate to the patch folder, all files, and select the one with extension patched. And you see right away that the second header has lost its structure. It is not pad row pad as in original, it's just row and pad. And in the first header, it's just raw and should be pad and raw. So how do we fix this? First, we have to find what exactly has UEFI patch changed. We see in this command prompt that 2 changes have been made. So let us, in our folder, patch folder, let us open the file patches.txt. If we search for these 2, those are the bytes in original file, and these are the bytes that were changed. So on original file, FF00 starts under the PCI bus, and 0FB7 is located in IVTQPI header. So these are these files. Okay, so we have to extract from the patched file, we have to extract PCI bus, that is at the beginning of the driver section, select the entry, right click and extract as is, and save it as PCI.ffs. Okay, so we could also do it with IVTQPI. Where is it? Second section. Here. Extract as is IVTQPI. But it won't work with this one. For some reason, the structure of this second header always changes if you try to insert this into original BIOS. So we will do things like this. Open MMTool, open the original BIOS from the patch folder, MSI.ROM, and find PCI bus. That is the body that we extracted. And now go to the Replace tab, browse, and select PCI.ffs. Open and replace. Let us save this image. So if we open that MSI.ROM image that we just saved, you will see that the structure is the same as it should be, as the original, but we have injected our new PCI header from the patched file. So ideally, we should do the same from the volume 2 to IVT-QPI. But as I said, if we try to do it like this, it will give errors, always gives errors. Maybe in your example it won't, but I know here it will. So how do we get around it? Well, one of the things, the thing we will do is open both files in hex editor and change the values manually. So start your hex editor, open the MSI.ROM original file and open MSI.ROM.patched, the patched file. Put them side by side. So we know what values have been changed. And now we will search for that values in the BIOS. So let us start with IVT-QPI from the patched BIOS. Copy all of this. So those are the bytes that were written. Go to the MSI.ROM.patched, Control F, change to hex values and paste it. So it jumped to this line, and those are the bytes we are searching. In the original BIOS, these were the bytes. So copy them, search, and go to. So make sure that the line number is the same as in here. So yes, it is the same. And let us, from the patched file, select all of this from D2 to BA. Copy. And in our original file, select from D2 to the beginning of the line, right click and paste right. And now save it. Let us open this saved BIOS to see what will happen. Okay, so the UEFI tool says this: invalid data checksum 38 should be 83. Okay, let's close it. Now open UEFI tool NE, that is the second UEFI tool here, and open our file from folder patch MSI.ROM. It also contains invalid checksum, but we know where this checksum is. It's on the IVT-QPI header. So let's find it. That is this one here. And as you can see, it says data checksum invalid, blah, blah, blah. But what we are interested in is this offset. So let's copy that offset. Go to hex editor to our MSI.ROM file. Search, and now go to paste the offset, delete H at the end, and make sure that offset relative to beginning is selected. So we are now at the start of the header IVT-QPI. And what we need to do is search for the value 38. Okay, so search, find 38 forward. Okay, this is this byte. So in Notepad++, create a file and let's take a look. It should be 83. So type 83 in Notepad, copy it, right click on 38 and paste right. And now save the file. And let us open this file again. No, we don't have to use the NE version. Let us use the regular version. And as you can see now, it doesn't complain about invalid checksum, and we can proceed to the next step. So let us copy our modded BIOS to the next folder DSDT. So as last time with Asus BIOS, we need to extract AMI board info with UEFI tool NE. So go to the DSDT folder, expand driver section until you find AMI board info. Open compress section, PA32, right click, extract body, and delete everything. So the file is named amiboardinfo.efi. Okay, now close this. Again, we continue with DSDT patching as in the guide, but let us first navigate to DSDT folder with command prompt. So first thing to do is step number 3, this command. Then ESL DSDT.MAL. Let us rename DSDT mod and open it with Notepad++. Now from the fixes here, from x79 section, we will do everything the same as the last one. So let us copy this, search for it. Oops. Oops. We also have 2 entries. So let's start with the first one and change it. Just a copy and paste this code from the guide. Justify it. And copy and paste it to the other section. And oops, I didn't copy the whole code, of course. And we also have to change the values to reflect the variables we need. So and save the file. So let us continue with our DSDT fixes. Well, the first one was this PNP 0C4. Let us find that. One entry, second entry. As you can see in MSI BIOS, both entries are lowercase, so we need to fix them both. Okay, just go to the first one, delete this, PNP 0C14, next entry. Okay, so let us now do the replacements. Go to Replace tab, regular expression, copy this, replace with this, replace all, Okay, now the next one. And now let us find the Y04 variable and change its value. Let's save the file and let us file it. SL DSDT mod.dsl. And now we have one error. So let us find what is that error. Scroll up. We mark. You will see the entry error here. This error. So the error is at line 2501. Input output decode 16. So that is this fix from the guide. So we have to remove the whole section at the line 2501. So let's go to that line. 2501, that is here. Select everything and delete. Now save the file and let's run the tool again. We now have no errors and the file is compiled correctly. So we need to now create a new AMI board info with command number 7. Copy it and paste. Okay, so now we need to inject this new AMI board info into our original BIOS here. So do that. Start a UEFI tool. Open our BIOS from the DSDT folder. Extend till AMI board info section. Compress section. Image PE32. Right click. Replace body. And select AMI board info mod.efi. Okay. Save the BIOS, but under different file name, test.rom. Let us open it, and of course, the padding issue will be evident again. But to fix this, we will extract from our modded file our modded AMI board info. Right click on it, extract as is, name it AMI.ffs, close this UEFI tool, and we will now again replace the body with MMTool. So start it, load image from the DSDT folder, MSI.rom, go to AMI board info, replace tab, browse and select AMI FFS. Replace and save image. So let us check for the padding errors. Okay, as you can see, the second section has correct paddings, and let's see for the first one, and the first one has correct paddings also. So the modding of this is done. Let us copy the BIOS one step above and edit the BIOS with AMI BCP enable above for G decoding. So in this MSI BIOS, this settings is located under Advanced PCI Bus, PCI Subsystem Settings. As you can see, above for G decoding enabled. Of course, you could change all settings so that Optimal will automatically load the settings that you need, but I'm just doing here, let's say, the safest settings possible. So we have now under optimal enabled above 4G, and under failsafe it's disabled. So if there will be any problems, you can just reset the BIOS and it will be disabled. So we now have to change the boot settings for optimal just to be UEFI, nothing else. And under Windows 8 configuration, I like to put Windows 8 configuration here enabled, but a secure boot was disabled, just in case. You can always enable it later, but for now it's be disabled. So last thing to do is to disable CSM. So you would expect that since we selected UEFI only in the optimal menu, that it will be disabled, but of course it won't. And where is the CSM section? You can see that it's not under boot, and after sorting you will find it of course under section games. So open CSM, as optimal disable it. Choose UEFI only or UEFI first. No, you don't need to launch for the network. And that's it. Save the BIOS. And that BIOS is ready for flashing. For MSI boards, you will see that the flashing program, that is this one here, once you run it inside Windows, it will create this file, that is the BIOS file, and these two, one folder and one file. So I know what is the name of the BIOS, so we'll just copy it. So let's say now on the MSI board, we will start this program and it will unpack this file and these files and folders. So without closing this program, it will be the Imperial Standard program. Rename our modded BIOS to reflect the original. Without closing the flashing program, just copy it to the USB in root folder and then continue with flashing, and it will flash our modded BIOS, and of course that will be it. So thank you for listening. Thanks Fernando and Xcurio for their drivers and their guides. Happy modding and good luck.